So here's our paper. We practiced these last time. Our paper is 13 by 9. We're going to cut out the corners, fold up the flaps, just like we did before. We need an equation for the volume. We need our domain. And we need the maximum volume. Now, we talked about this yesterday, that these problems are very much patterns, right? They're the same thing over and over again. So what is our volume going to look like? It's going to be 3 things: volume, length, width, height. 3 things. What are the 3 things if the paper is 13 by 9?
Something minus 2x.
So 13 minus 2x. That's right, Tayshawn. 13 minus 2x. 9 minus 2x.
And then x.
X, yes, there we go. Team effort, good job. So, dimension minus, the paper has dimensions. Dimension minus 2x, dimension minus 2x, x. Every time. Then our domain. X is going to be between 2 numbers, always. What is this number always going to be? 0. This number will vary depending on the problem, but you'll always find it the same way. How do we figure out what number goes there?
Half of the smallest side.
Half of the smallest side. So the smallest side in this problem is 9. So half of 9 is 4.5. Now I'm going to graph this on my trusty calculator. But before I graph the equation, I have to set up my window. I already know what my x's are going to be. This is x min and x max right here. And then what's y min? Always. Y min is 0. And y max is our guess. Remember? Because whatever we do, we want to be able to see a hill when we graph it. So what's a good number? What do you want to start with this time? Just guess.
900.
900. Ooh, that's a big one. Let's see what happens if we start with 900. All right. So I'm going to go to my window, and I'm going to type in those numbers. I'm going to type in my new equation. Sometimes we forget to type in the new equation. We need to go to y equals and type in that equation. Well, I didn't exactly see that. I saw more like this. And that's okay, that's fine. But the reason that's so squished up down there is because we use 900. So why don't we, just for fun, let's change that 900 to a 200. And I bet we get a better hill. And Mrs. Ford never knows at the start of the problem. I have to guess just like you do. So I'm going to guess just like you. I'm going to try to figure out what the big or best number is. Olivia?
I have enough height, but how do I get more length so I can see the whole thing?
Okay. This is the width, but you're not changing that. This is x min and x max. That's definitive.
I know, but I can't see the end of the...
All we care about is seeing the top of the hill. Can you see the top of the hill?
No.
Okay, well then something's wrong. Go back and check your equation. Maybe you typed in your equation wrong. Once we get our picture, then we second calc, maximum enter, and And then we set our left bound, our right bound, and put it in between. And I got my maximum. My calculator says 1.74 x, and y is 91.44. Who got that? Who got that maximum? Good. Now we have to interpret it. Gotta answer the question. What is the maximum volume? What are you gonna put in the answer blank? The y value. So 91.44 is inches, cubic inches. Yep. Alright, if you can't figure that out, you need to go back and watch yesterday's video, or find a friend, sit down, or come to office hours, or go to the learning commons. Okay? Alright, here we go. Find the final cost of your new uniform pants if the price tag says $33.50, but there is a 15% discount and there is a 7% tax. So our pants cost $33.50, so we start with that number. And now we're going
Pardon this interruption. It is now time for all choir members and anyone else involved in the rosary presentation to head to the WAC. All other students, you are to head to your E period. After the end of D, you are going to drop off your bags. They will take attendance. And do not forget to bring your rosary to the living rosary mat. Thank you.
Okay, so we start with $33.50. We're going to multiply that by a couple of things. We're going to multiply it by a number that reflects 15% off. So 100 minus 15, what will that number be? 85.85. Remember, these are percentages, so they're decimals, 0.85. And then 100 plus 7, that decimal will be 1.07. And we just simply multiply those three numbers together. And we get $30.47. So your bill will be $30.47 when you buy your new pants. Okay. This is a how much problem, so we're going to have amount times percent plus amount times percent equals amount times percent. Boys and girls, we're doing a practice test. What does this tell you about the test? This is exactly what your test looks like. So you're going to do a box problem. You're going to do a I'm buying something problem. You're going to do a let's mix stuff together problem. Okay? So here we go. Amount times percent. Okay. How much 45% cocoa should be mixed with 32 ounces of 75% cocoa to get cocoa that is 58%? Do all of those numbers in those spots make sense to you?
Yeah.
So then I gotta fill in the one that's missing. 32 plus x, or x plus 32. Because we know that whatever goes here is this one plus this one, right? Every time. Every time.
Sorry, I'm not sure if you said this before, but would the plus x always be, would the x always be positive, or could it be like 32 minus x?
If it's here, it'll be 32 minus x.
Okay.
All right. Now let's solve it. So we can use our calculator to help us with the arithmetic. I got 41.85 ounces. So I just multiply all this stuff together, distribute there, and then move stuff around. So all the x's on one side, all the numbers on the other side, and then I divide it. And got 41.85 ounces. One more word problem, and I think that's it. Last year, the team won 19 games. This year, they won 24. We want to know the percent of increase. We have a little formula for this. What's our little formula for percent change? Difference over original. You two had your lanyards on before, where are they? Thomas hasn't had one on all period. Okay. So, what's the difference here? Difference is 5. Original is 19. That's all there is to this problem. It takes about 5 seconds. 5 divided by 19 is about 26.3% increase. If you want to find percent change, percent increase or percent decrease, you take the difference and divide it by the original. And that's all there is to it. All right, now we've got some random questions here. Let's see if we can remember how to do this. Find the direct algebraic relationship between x and y. Does anybody remember what we do to find a direct algebraic relationship between x and y?
Elimination.
We eliminate the t. We don't want the t. We want just x and y. That's what the problem says. So we're going to eliminate the t's. Now, things are not lined up very well here in this problem. So I'm going to go ahead and rewrite the problem so that when I eliminate, my t's are in line. See, I just flip-flop these two so that my t's would be in line. Now, how will I eliminate the t's? What will make that happen?
Multiply the top by negative 2.
That'll work. So negative 2x equals negative 2t minus 8. And y equals 2t minus 3. So I'm just simply multiplying the top equation all the way across by -8. Or by -2, I mean, multiplied by -2. And then I'm gonna add, so -2x plus y equals -11. That's it. Started out with 2 equations. Now we have how many equations? 1. And what are the letters in that equation? X and y, which is exactly what the problem asked me for. I can't remember if we talked about this, I know we talked about the idea of this problem, but I don't know if we've ever actually done this problem. What does it mean to be inverses? X and Y are switched, right? That's what happens, you switch the X and the Y. So let's just do something here for a minute. Roxy, pick a number, not too big. 10? Okay, 10. So I'm going to take Roxy's number 10, and I'm going to put it into this function. So what would f of 10 be? If I plugged in 10, what would that give me? 16? Wouldn't that give me 16? Now, I'm going to take that 16 and put it into G. So I'm going to put 16 now into the G function. What does that give me? With 16 here, what do you get? 12. These are not inverses. Because if they are, 10 would give us 16, and 16 would give us 10. Because this is the ordered pair, 10 comma 16, and this is the ordered pair, 16 comma 12. If they're inverses, they're supposed to be the exact same numbers, but turned around.
What would you put?
I did not get back 10. I was supposed to get back 10 using the numbers I chose.
Yeah.
You'll pick your own numbers.
Yeah.
But you have to end up with the same number that you started with. So if you picked a different number, let's say you picked 3, then you got 2. So then you put your 2 in here and you get 5. Not right. You got to get back the same number that you started with because the ordered pairs have to switch. So for that problem, you're going to pick a number, any number. Stay away from 0 and 1 because they're kind of special. Just pick some other number, random number. Plug it into the first function. Take whatever answer you got, plug it into the second one, and you got to get your original number back again. All right, 8, we're going to find some inverses. Well, you had a quiz over this. Well, not over A. A's easy. What do we do to find an inverse?
With the X and Y.
Switch the X and Y. And then get Y by itself, right, Avery? So we're going to move the 4 over. We're trying to get Y by itself, so what will we do next? Subtract the 9. And then divide by -2. And there's our inverse. Do one more. We gotta do B, because we know how to do B. changed this to a y. And then we switched our variables. Just like we did over here, this one probably was easier.
Oh, and then we just take the 2 y.
We brought this over to here, and distributed. And then what? This is where some of you found issues.
We should take out the x.
No, we don't take out the x. If you take out the x, you're gonna be right back where you started. What do you have to do? You have to get the y's on the same side, and then you're gonna take out a y. The y is what you want to take out. Another place we ran into issues is, guys, if you're moving the 3y over to the other side, don't you have to make it negative? Don't you have to subtract it? And the same thing with the 4x, it's gonna become negative. Now, I can factor out a y. And then I can divide. So y equals negative 4x minus 5 over 2x minus 3. Some of you mess up this order. I would recommend you actually write down what you're dividing by to make sure that you have it set up correctly. Did I say Manchester? One of my kids went to Manchester. Okay, you good with that? All right. Next one. Oh gosh, you can do this one. Given these two equations, find the point, you're looking for a point. If x equals t squared, y equals 5 plus t over 3, and you know t is negative 1. We're just going to plug in negative 1 for the t's. So negative 1 squared is 1, so x is 1. And then putting in negative 1, 5 plus negative 1 over 3. 5 plus negative 1 is 4 divided by 3 is just 4 divided by 3. So what do we do on that problem? We just fill in the t. Fill in the t. Very, very easy. All right. Now, consider this picture. While I am drawing it, would you take a moment and label every point? So we have 0, 0, we have 2, 1, and we have 3, 0 on this side. And then we have negative 1, negative 1. Negative 2, negative 1, negative 3, negative 2, and 1, 2, 3, negative 4, 0. So there's my picture. Now I'm going to sketch it in a minute. Let's do B, C, and D first. B, is that picture a function?
Yes.
Yes, because it passes the vertical line test. So this is question B. It says, is this thing right here a function? And the answer is yes. It passes the vertical line test. Question C says, is its inverse a function? No, because if the inverse is a function, this picture has to pass the horizontal line test. Does this picture pass the horizontal line test?
No.
No. So the answer to C is no, because our original picture does not pass horizontal line test. Now, what about D, 1 to 1? Is it 1 to 1?
No.
No, because what does 1 to 1 mean?
It's both.
You pass both. So it passes vertical, it does not pass horizontal, so it is not 1 to 1. Now we're gonna graph the inverse. You remember how to do this? It's really easy. What do we do to graph the inverse? We take every point, flip X and Y, that's right. So, I'll just start right here. Instead of -4, 0, I'm 0, -4. Instead of -3, -2, I'm -2, -3. -1, -2, -1, -1, 0, 0. So connecting what I've done so far, that's what I've got. This would be 1, 2. And this would be 0, 3. To graph the inverse, all you have to do is flip the ordered pairs. All you have to do is flip the ordered pairs. Okay? Now, we're gonna finish the last problem. There's only one to do. We're gonna finish it. Then we'll be done with this practice test. All right, so here we go. This is the original picture. So the original picture is a triangle, a semicircle, and then a lower triangle. Is everybody okay with that? That's the original. Now, let's look at what I graphed. How did it change? Let's make a list. What's different about figure 2?
Upside down.
Okay, it's upside down.
Sideways.
It's upside down and it's flipped sideways? Is that it? That's it. So I gotta write an equation now that shows me that I'm upside down and I'm flipped sideways. How do I do an upside down flip? Negative in front of the F. So it's gonna be negative F. This is F of X. I'm turning it upside down, so I'm gonna put a negative in front. Now, how do I make it flip sideways?
Negative X.
A negative on the X, so my parentheses and negative X. Won't that equation right there flip me sideways and flip me upside down? And that's what I wanted to have happen in my picture. Practice test 1, done.